Okay, so now we want to find a vertex and an axis of symmetry of a quadratic function. So I don't want to get too crazy about talking about this, but let's talk about it a little bit. So we know that quadratic functions have this parabola shape, right? So they look like this. We usually label the vertex as HK, just to give you letters that aren't XY. So the vertex of a parabola, we label it HK, and it's right there. It's the point that is the minimum or maximum value that this function is going to take on. So with this one, it opens up. So that means that this vertex is representing a minimum value because that's the lowest value that the function takes on. If it were the other way around, then you'd have, your U going, or your U-shaped sort of thing going that way. And now this one would be a maximum, and we still have that axis of symmetry running down the middle. So anyway, if it opens up, that means that our vertex is a minimum. If it opens down, that means our vertex is a maximum. So this standard form business is wonderful. When we talked about just the general graph of something that looks like y equals x squared, so we can draw a picture of this really, really quickly by plotting points, right? And we know it looks like a parabola. We know that it's got 0, 0, negative 1, 1, and 1, 1, and we can draw it really, really quick. Well, all parabolas look like this one, and if we talk about it in terms of transformations of functions, we can do just that. So we could take our vertex on this one that we know is 0, 0, and we would move it to the right h units, and we would then multiply it by a factor of a, and then move it up k units. So this isn't really going to do anything to us vertically because it's already at 0, 0, and multiplying 0 by anything is just going to leave you at 0. So all we're doing with our vertex is we're in the standard form is we're moving 0, 0, we're moving it to the right h units, and we're moving it up k units. So our vertex is hk, and that's, well, just our vertex, maybe talked about, explained kind of in a transformational sort of way with transformations of functions. So the problem that we have, though, doesn't look like this. And if it did, boy, that'd be wonderful, because then we could just immediately say what the vertex is, and that's, slam dunk, right? So we're given this, and that's different, right? This is, usually they call this general form. So anyway, we have this, and we want very desperately something that looks beautiful like this. Well, what we can do, if we really wanted to, we could just complete the square, right? So we could factor this in such a way that we would have a perfect square, and it would kind of look like this, but we would have to do a bit of work, and we don't really want to do that. Because it's already been done before, and maybe we've done it a few times in our practice, and maybe you've done it before, and that's wonderful because we should be able to complete the square because that's kind of a useful skill just in general in math classes. But what we do is we could, if we wanted to, complete the square on this general form, and if we did that, we would find that, well, it would look kind of like this, but in this position, you're going to have this, and we're going to need to find that y value. Anyway, that's a lot of words. Maybe we want to talk about this deeper at some other point, but for the purposes of this nice video, we've got a nice little formula there, and we can sure use it. So the vertex of any parabola at all, we can find it using this, right? So with our case, we just want to know what these coefficients are, and hey, we're home free, right? So this, we just match them up. So this guy here is going to be A, this guy here is going to be B, this guy here is going to be C. All right, so we can do this in little pieces. First, let's find negative B over 2A. So negative B would be negative 7 over 2 times A, so that would be 2 times negative 4. So we can simplify that. Our negatives are going to cancel out there, and that's going to be 8, so we've got 7 over 8. Okay, so now we need, so this is the x-coordinate of our vertex, right? We just found this. Now we want to find the y-coordinate. Well, if we want to find any y coordinate that goes with any x coordinate, excuse me, any x value, we just plug it into the function, right? Whoops, I didn't mean to make that look negative. So we can just plug this into the function. So we got f of 7/8 is, and then we can just plop it on in there. So we got -4 times 7/8 squared plus 7/8 minus 6. And now, so all that's left to do really is compute this out. I trust that we can compute this, right? Maybe right now is not. I'm just being lazy. I don't want to do it. So I should probably do it, right? So we can do this. So we got -4 times 49/64 plus 7, so that's 49/8 minus 6. Okay. We can do this. So that's divide by 4. You know what? I absolutely trust that each and every one of you can compute this. I'm going to use the calculator. So we want to do -4 times 7/8 squared plus 7 times 7/8 minus 6. And provided I did not make a keystroke error, this is -47/16, and that's great. Let's be humorous here. Magic happens, right? So we found the y value, and now we can just say what our vertex is. So HK, our vertex, is the point 7/8, -47/16. I don't think we really lost anything there with using the calculator, because you got the technology. Why don't you use it? So great, we found our vertex. That's wonderful. And that's not the whole task, though. We wanted to find the vertex and the axis of symmetry. So once we have the vertex, though, I mean, we're home free, right? Looking back at this picture here, the vertex is the only point on this parabola that doesn't get reflected, right? So this is the point that is on the axis of symmetry, because everything is reflected about that line, right? That's what the axis of symmetry is. Anyway, if we have the vertex, we know that the axis of symmetry goes through the vertex, and it's going to be a vertical line. All vertical lines look like this, so we're home free. The axis of symmetry, maybe I'll write AOS, axis of symmetry. This is the vertical line, x equals 7/8. And that's it. It might also ask us if the vertex represents a minimum or a maximum value of the function. And we're going to decide that based on whether or not the parabola faces up or faces down. And we decide that by the value of this coefficient. So if this is positive, it opens up. If it's negative, it opens down. Maybe I'll write that down. That'd probably make it a little too busy. If this is bigger than 0, then it opens up. If it's smaller than 0, then the parabola opens down, and we can decide if it's a minimum or maximum at that point.